All right, today we're going to talk about some operations on the manual mill, a little bit of setup, and a little bit of how to do some different things. When we have a part, the first thing we're going to do is we need to make the length, the correct length, and so we're going to use an end mill to do that. So typically we have these parallels that are in the drawer that we use, and if we put our part in, this is a hex part, some hex stock, so if I put it down, it's kind of hard to see, but it's not sitting real deep in the vise here. So in order to mill, I can't mill across here. I'll mill my parallels in my vise. That's not a good thing. So it's not hanging on by a whole lot. So sometimes we need to get a different parallel that's a thicker parallel, and there's just one. So it's just got a touch, so it gives us a little bit more of a depth to work with here. So there, that sits a little bit deeper, but I still need it to hang out. This hex I'm clamping on the flat. So now it's tight. Now we need to talk about spindle speed. Obviously, you know that we need to do the math, 3.82 times 150 surface feet, because that's what we're using for aluminum in this particular case, divided by the diameter of the cutter. On the lathe, it's the diameter of the workpiece. On the mill, it's the diameter of the cutter. This is a 3/4 inch cutter. If I do my math, I come up to about 800 RPM. So on the side of my machine, I have low, neutral, high. That's where this is, low, neutral, high. It doesn't always go into gear, so you have to turn the spindle to get it to drop into a gear. Show you what I mean. I need two hands here. So I'm going to turn it and push the lever. So I hear it click in. So you got to push this in. And you can't see my hand up there. Let me get it. There, it's this lever. So I got to push it in and then rotate it to go. And I got to turn this because it doesn't always, here, like the lathe. You got to turn the spindle while you're changing the gear. So it's in high gear, which means I get to go off of the high chart. You cannot turn, well, I mean, physically I can turn this now, but if you turn it now, it screws up the numbers and you won't be going at the speed it says it is. So everything's clear, turn the spindle on. Forward for high. When we go into low gear, you go the other way in reverse. The reason I know this is because if I look at my end mill, it's going this way, so my cutting edge is here, not here, so I need it to go around this way, and that's that way. See? All right, so I got that. Now I can change my RPM, crank the dial till it's about 800. Now I'm good to go. Get you set back up here so you can see. So, I come down to the stop and lock the quill. Here's the quill lock. Doesn't have to be killer tight, just one finger snug is good. Now this thing's not going to be able to move up and down, although I can loosen it and raise it up. In order to come to the same spot, I lower it back down. So I'm going to move off the end of the part. I want to make sure the locks are not locked. So I'm going to go over to the end of the part. So in order to get down there, I gotta raise the knee. then I want to get the cutter so that it is below the part. Now the very bottom of the cutter, use the brake so it stops. The very bottom of the cutter is where most of the force happens. So the very bottom, these points sometimes get dull. So go down far enough so that I'm really cutting from here to here. And then I don't have to worry if that's not quite as sharp. So while that's off, I'm going to move away from my part. Get you so you can see better. See, I'm away from the part, and now I'm going to come here. Now, since my flutes are this way, and it spins this way, okay, I can't move the table from front to back. That's called climb cutting, and it wants to pull it fast, and then you get a lousy finish and things jump around. So when I'm milling on the left end, I want to start in the back so that as I'm cutting, it's going against the feed. So just like this, from the back to the front. So what I like to do is get onto the part, but stay away, turn the spindle on, slowly move into the part, just like we do facing on the lathe. Just barely touch. Oh, I hear it, I see it. Slowly move to the back. So I'm all the way off the part. Digital readout. Showed this on the other one. I can set my X 0 so I know where it touched, so I know I can move over 20 thousandths, 15 thousandths. I should lock my X so it doesn't move on me. And now I make my cut. Coming out nice and easy. I should have oil. I just don't have it with me right now. Oil makes this finish. Now when I'm going back in this climb, this is what I'm going to call a zero pass because I didn't move my x-axis, and if I go nice and easy, I'll get a nice finish. I'll show you what I mean. Have a really nice finish. Okay? Just like on the lathe, face one end to clean up, take it out, deburr, face the other end to clean up. So I'll put it back in, face the other end. Now here's the thing, if I just took this pass, I need to know how long it is. So once I did one end, deburred it, flipped it over, now this is my second side I cleaned up. I'm going to take my caliper, the dial caliper. Notice where my dial caliper are. They're in the box, it's closed. If you leave my box open, and it's like this, those chips that just flew off my part are going to fly into here. When they fly into here, they'll get caught in the teeth. Okay, remember we talked about this? There's a gear rack in here. When the chips get caught in the gear rack and the plastic gears on the inside and you close it, you just ruin the plastic gears. This thing jumps gears and then it's no good. Okay, I have some nice calipers this year. So you're not using them, they're in the box and the box is closed. Pretty simple. I expect to see it. So, if my part I need to measure, if I crank out back farther, I have plenty of room to get in here with my dial caliper and measure it and make a determination as to how much to cut off. If I only have 22 thousandths to go, if I go back to my digital readout, because I made the last cut, I set my 0, now I know if I move over 22 thousandths, lock it again, make my cut, I should be exact size. So, close my caliper. So that is milling it to length. Okay? First operation. So now I'm going to do the next phase. So I want to use the stop as often as possible, because if I put this up against the stop and I edge find the end and the back, I can either do the back of the part or the front of this back jaw. They're the same surface, okay? So Y0 is here, X0 is here. So let's say I already milled or drilled this part. In this particular part, it's pointed or a round part, I would have to mill a flat first. On our print, we are going to mill a certain distance from the end. So let's say I already did edge finding, which I've showed you that process in a previous video. So let's get this on here, not me. Okay, so I'm going to come over here, and I am going to go back to where my 0 was. Okay, so my digital readout's 0, 0. I read my print, I move over the right distance. I think to the center of this it was 3 1 1/4. That's what it was, 1 250. I'll go there. Lock my X. And now I'm going to have to mill down a certain amount. So what I'm going to do is lower the table, come down to my stop, lock it on the stop. Let's see a little bit better going here. Lock it on the stop. Now I've got to touch off the top. So if I turn my spindle on and I raise my knee till I just barely touch, barely touch. See, I can't drill a hole in that point because there's a point there. It'll walk off. So there, I just touched, so I'm going to move out. I'm going to look at my print. My print tells me how far I have to go down. Obviously, I can't make it in one pass. So I'm going to make a cut from the back to the front. All the way off, go back. Lower it some more. Again, I should be using oil or lubricant or something of that sort. I just didn't get it for this video. I think this is my last pass. Yep, right on the money. So now we need to drill a hole right in the middle of that. Now, if I try to take my cutter out of the spindle right now, up top, where the drawbar is, there's nothing up here. That nut's not there because it traveled down when this quill came out. So you got to loosen the quill up, and now it's there. So now you can take this out. Remember, I push it to the wall, or I rotate around, hold the brake, and then pull it towards the wall. So it's loose. 1, 2. Hold the end mill and hit it. Now my end mill came loose, and it won't get out. So I gotta lower the table. So we're taking this out because now we're going to drill a hole, and we need to use the chuck in order to drill a hole. Okay? Put Put my end mill back in the tube. Take my brush this off. The tools that I have are center drill. Always use a center drill. Then my drill. I got this information off the print. Then I have a tap. Okay? So I put the chuck in, so again I need to lower it. So anytime I lower the table, as I said in my other videos, after you lower it, when you go down, you want to come back up a turn to set the knee in the up so that there's no backlash. Now I take the chuck all the way out, so sorry, collet. So there's the collet. Now I should be able to put my chuck in. Don't forget to look for the key, don't just slam it up there. Tighten that up. Tightening comes away from the wall, or if you're looking down from the top, righty-tighty, clockwise, there's that. So, I need to calculate my drill, my RPM, based on my drill size. So, this particular one is 1/4 inch roughly, so 153, 600 times 4. So about 2,400, but we got to put this in first. Got to use the chuck key. Now remember, I already found my 0, so I just got to go to the right spot. So my right spot is
Teachers, please excuse interruption. Students, tonight's historic football team takes on
right
the
there.
High School at Elgin High Memorial Field.
Now sometimes
Game times at 7:30 p.m.
this is
and
up too
tonight is
high.
Channel Night. So wear your best channel and support the storm tonight. Have a great weekend.
So
Thank you.
lower it, jam them against each other so they don't move. Okay, now I can't get all the way down, so I gotta raise my knee up. So on this spot drill, or center drill, sorry, we want to go this pilot in and then up this angle a little bit bigger than this diameter. So I measure this, I happen to know this is 1/4 inch, so I know my need to go up a little bit more than 1/4 inch. Turn on my spindle, turn up the RPMs, and I'm gonna go nice and easy. Peck it to break the chip. See, it's starting to get a taper. Never do anything with the spindle running, turning it off, then brush your chips. Now I'm going to get my caliper. Well, actually, I can just use my tap. A little bit bigger. Turn it off, brush it, check it, looks good. So now I got to put the drill in. Now notice I have all my tools here. When you're going to drill a hole, figure out what you need to drill the hole and get all the stuff you need. Otherwise, every time you turn, oh, now I got to go to the cage. I got to get the tool. I got to come back. Oh, I got to go get the tap. Go to the cage. Oh, I forgot the tap handle. You'll be there all day, walking back and forth, because you didn't plan. And so you'll only get a center drill done. Not a good plan. So this hole goes all the way through, as I read the print. So the way that I do this is I take this on the left side and I wipe it. So in the hole a little bit, out, wipe. In, out, wipe. Wipe. When I wipe, I brush down because it also breaks the chip off. Every once in a while, I got to get some additional oil. This thing doesn't have to take a total bath, but we're brushing the chips off. And we're going all the way through. A little more oil. Yeah. So, remember we used this parallel? Look what happens if you don't take the parallel out. Drill in the parallel. Don't do that. So I got to take the parallel off and see I'm already through. Don't do what I just did. I'm going to have to go and deburr that and fix that. All right, so I'll take care of that. I'll fix that parallel. So fortunately, that parallel wasn't hard. Most parallels are hard. They're harder than the drill bit. And if you did that in a hardened one, it would end up breaking the drill bit or burning it up. And you'd be like, why won't this work? All right, that's why. So take the drill out. Put this tap in. Now tapping, we don't do it with power because bad things happen right away. Okay. So we're going to do this by hand, turning it by hand and everything. So here's something that matters a lot. This thing right here. If I'm coming down and it hits this before I decide to stop on this tap, it's going to strip the threads out because it's not going to come down as it's turning. Get you back out here so you can see. See all of that? Yeah, there we go. You can see that a little bit. All right, so if this gets in the way before I get down, okay, it's going to hit this. So we're going to turn, and it's going to be like a screw. As I turn this, it's going to feed down, okay, because it's going to thread in. It's going to spiral down. If it hits this, it can't spiral down. It stays there, but I'm still turning it. So what happens is it just makes the hole the same size as this. It wipes out all the threads. So it's really important to make sure that this is farther away than where we're going to go. Well, that's easy enough to do. Look at how much space I got here. Raise the table up. Bring it down, and I can see I have a lot of room up here. So now I have to put it in neutral. Remember up here on the side, put it in neutral, so look it spins free. This is another time that you won't be able to loosen it up because the brake doesn't work because it's in neutral. All right, so I'm going to take this, dab some oil in here, put some oil on the tap, bring it down. I got like 1 finger pressure on this, okay, 1 finger pressure. And then I'm going to hold it, and then I'm going to turn. And as I turn, it goes down. And if you watch, you can see it's going down. Big taps get harder to do, but now it's in there, started pretty good. Now I really don't want to let go, but I could. See, my hand's off of it. Now, I need to loosen this up to get this out of the way so we can use this tap handle. And we'll finish it with a tap handle. We'll put it on the tap, we'll turn it, it'll tap the rest of the way. Problem is, if I just loosen this, this thing's going to whip around, okay? So I'm going to lock the quill now, okay, lock it, so that when I loosen this, it's loose. Now, I'm going to show you what you don't want to do, and hopefully I won't get hit. But what happens is everybody likes to just loosen this up. Well, look where my hand is. This thing's going to fly around, and it's going to hit you right here on the bump on your bone. How do I know? Done it before. It hurts a lot. So I'm going to hold this. Now I'm going to loosen it, and now I'm going to slowly bring it up without getting my wrist wrecked. Okay, so home stretch. Get this out of the way a little bit. I'm lowering the table, so that means I got to make 1 full turn coming back up. So, most likely I need a little bit of lube. I'm going to take this. It's a square turned sideways like a diamond, so make sure the points are on. And so now I'm going to just turn this. Now don't grab on one side and pull off to the side because that's a really good way to break the tap. Okay, and then it's broken your part, I can't ever get it out, and your part will be scrap. Start over. So I go about a turn, and then I want to back up a little bit more than a turn, because sometimes a chip gets stuck in there. So I want to go back and make sure that that chip breaks off and gets out of the way. On a through hole, it's not so bad, but on a blind hole, or one that doesn't go all the way through, there we go, back up. We should put a little more lube on there. And I'm going to keep going until it goes all the way through. Back it up. There we go. I'm done. So now I can back this all the way out. Notice I'm keeping two hands on this, so I'm not leaning, because if I lean, it's going to be a problem. Now I can spin this out. No, too tight. There, starting to wobble. There's the tap. And there's my part. Milled to length, flat milled, tapped hole. This part, all it's going to need is these ends turned, okay? And I have enough room to, I can grab it and turn this, and when I can flip it around, grab it here and turn it, even though that's there, I still have 3 jaws that I can grab hold of. So, that is milling the length, center drill, drill, tap. Most of what you need to know to get the ball rolling. All right, see you next time.